you use it tonight or use it in the future, I hope it is helpful. As some of you know, one of my beliefs when we do statistics examples is to try to do them in context and use some realistic data. I think this is a very realistic example. Well, one of the most fun ways to do this, if you look at the context here, imagine we're bringing in some hot coffee or hot chocolate or some hot liquid into a room with a known room temperature, and we just leave it sit there so that it cools down. It's actually very interesting, especially I think for students, if you collect a great amount of data. Perhaps you would record the temperature every minute for, say, an hour or an hour and a half. We even have the capability to connect a data collector called the EA200 and a temperature probe, and the advantage of that system would be to that the data would automatically be put into our lists. However, realistically this evening, we can't all collect the data, nor do we really want to enter 60 or 70 or 90 values in. So I've abbreviated our example and just say, well, let's take what the temperature might be each 10-minute interval. So this will give us a smaller data set to work with, but as you see here, I have one variable called time. Think of it as time elapsed since the coffee was brought into the room. We have another variable called the temperature, and there is a third column on this handout which will be more clear in a couple minutes as we go through the details of the example. So what we are going to do is begin our analysis by putting these values into our PRISM calculator and then go through some analysis and talk about a model that is appropriate for what we have. Last week, for those that were here, the difference this week we did a set of data for which a linear model was pretty appropriate. The data was fairly straight when we looked at that plot. Here we're going to see noticeable curvature, and so we're going to do some things a little bit beyond what we did with the straight line regression. So let's get a PRISM calculator on the screen. Again, I'll give a few, I hope, helpful hints about how we will navigate. An important key is right here. I kind of have our little red spotlight on that. I hope you can see that okay. That is called the menu key. Another very important one right below it will be the exit key. Down in the corner here, our execute key. And up top, what we sometimes call our soft keys, or we'll just simply refer to them as F1, F2, and so on. We'll make some of these keys a little more clear as we go through the example. But let's all begin with pressing that menu key, and that should bring up the screen. So your screen looks like this with menu icons. Should be similar to mine. Hey folks, I just want to make sure we're in good shape here. So Nathan, I hope we are ready to record or have been recording.
Yep. Yeah, we're recording. So if anybody misses this,
okay.
Yeah, we'll post it.
Yeah, sorry to throw that in the middle of the recording, but one time we had a few technical difficulties. So that provides folks an opportunity to listen to this later if they're not able to join us tonight. All right, back to our calculator. We press menu. Notice the icon for statistics has this little character of a 2 in the corner. So the easiest way to get to the statistics menu is just press the 2 key. That should bring up a list editor. Now your lists, kind of like mine, may have some old values in there. Let's talk about how to delete values from a list. I know this is a repeat, but some of these are worth reinforcing. These little boxes that we see on the bottom of the screen, which I think we really call them not boxes but tabs, these tabs are what I was speaking of. Currently, the F1 key corresponds to the graph tab, the F2 key corresponds to the calculate tab, and so on. This little symbol right here really means there are more choices, more than 6, and so that simply means press the F6 key to see additional choices. So we press F6, some new ones come up, and now we see F4 corresponds to delete all. Delete all still only means one list at a time, but it will do all the elements in that list. So press F4, gives us a safety check. Do we really want to delete? F1 says yes. I'm going to scroll over to list 2, repeat that process, move over to list 3, repeat that process. Up here is a space. This is totally optional. It gives you an opportunity to put a label in your list if you wish. If you were going to do that, can I draw your attention to the red alpha key? And then once you've pressed alpha, then of course you just pick the appropriate letter to put your label in there. Actually, if you go shift alpha, it'll put it in alpha lock so that you can have type all the letters. So as a quick demonstration, if I go shift alpha, and then I could type the keys that correspond to T, I, M, E, and then the execute key down in the lower right hand corner, and I have that label. The 0 happens to be correct. To move to the next element, press execute. Perhaps I needed to go 0 execute, I'm sorry. I saw a 0 there. 10 execute, 20 execute, going in increments of 10 up to 90. So again, if you don't have your handout there, no problem, but please put in 0, 10, 20, 30, up through 90. And yes, folks, there is a way to use a sequence command that would be a little shorter version of that, but this one's not that long, and I don't think we want to detour to the sequence command right at this moment. We could do that at the end if someone would really like to see that. All right, a little glance to see that we're okay. Notice on the far left is actually like a counter that says I've used 10 rows of this table, so that is good. I'm going to press the cursor wheel to the right and put in these temperatures. First temperature was 200, 148. I'll try not to go too quickly here so that, again, people who would like to have the opportunity to work along on their own calculator. The third temperature was 116. The fourth temperature was 97. The fifth temperature is 88. The sixth temperature is 82. The seventh temperature, just to glance, see that we're doing all right. This corresponds to at time 60. The temperature is 77. 75. 74. 73. So what's happening is that the coffee is, of course, cooling down. The heat is going on this, I guess, a quest for equilibrium. So heat escapes from the coffee, and the coffee is approaching the room temperature. So hopefully at this point, each person has 10 pair in list 1 and list 2. Again, I can put the label of temperature up here. That really is totally optional, but I'll wait a second. If anybody had any difficulties or wants to type in a comment or a question, we'll wait just a moment, and then we'll move to the next part. If you are following on the handout, moving to page 2.
Yeah, we seem to be doing just fine so far.
Good, thank you. Here's a little convenience that I'm going to mention about scatter plots. We've already drawn attention to this menu key. Notice in the yellow characters above it, it says setup. So we access that by shift and then menu. So I'm going to do that. I'm going to push shift and menu to bring me to the setup because I wanted to comment on this statistical window. My calculator is currently set to automatically choosing a good viewing window for the scatter plot. That's convenient. I prefer it that way, but I do want to comment that you can overrule that with this choice of toggle it to manual should you prefer. Also, while we're there, the second choice here is, do you want to store your residuals? We did do that example last time. I'm not sure we'll repeat that experience here. We might if we have a little time at the end. We'll see how that goes. But I do know this. I have other intentions for both list 3 and list 4. So I'm actually going to change this to store the residuals over in list 5. Now how do you change that to a 5? Notice the tab above F2 is the list command. There's another way on the keyboard as well, but this is the easiest. And if I push F2, it simply says, well, which list do you want? In my case, I'd like to use 5. Execute, and that has just changed it. That'll automatically store residuals for any regression we should do. All right, that's all we really had to look at under setup. So how do we leave setup? We press the exit key here in row 3. Exit, and we're back to our list editor. I'm going to clean up this keylog window just because it's pretty cluttered. Now, you might recall that I pushed this F6 to bring up this delete all command. I want to go back where we were. There's a couple ways to do that, but one of them simply is, again, push F6. You actually see the third set of choices, or there's only one there really. Press it again. We're back to the beginning. To do our graphing, the tab above F1 says graph, so we're going to push F1. Here's something I said last time I'd really like to reinforce. You can immediately push one of the soft keys corresponding to graph 1, graph 2, graph 3 if you are sure that it is set up just the way you want it. Otherwise, the safe way to do that is to go over to the Set tab. In other words, push F6 and take a look. In this case, my stat graph number 1 is in fact a scatter plot with list 1 and list 2, so it's fine. That is what I wanted. But just to demonstrate, if this, say somebody had done a pie chart there, instead I would push F1 to change it to a scatter plot. If you need to change one of the list names, again, the same thing. Here's a list tab. Press F1. It'll say which list do you want. So we want a scatter plot of list 1, the time on the x-axis. List 2, the temperatures on y-axis. I'm ready to exit from setup, or actually just the graph set command. All I have to do to see the plot is push the F1 key for graph 1. And there we go. If you are looking on the handout and you see the corresponding picture, it has some nice grid lines there that kind of correspond, make it look almost like an old-fashioned piece of graph paper. Grid lines are a nice feature. You can have them on, off. You can have them as kind of a lattice set of dots instead of lines. However, please understand that the grid lines are determined by your scaling. What do I mean by that? Notice above F3, again in yellow characters, it's V window for viewing window. If I go there, Shift F3, because in our setup we made an automatic window, if you will, the calculator determined that this X-min of -15, X-max of 105 would show the scatter plot nicely with a little bit of space on both the left and the right. However, it did not do anything with the X scale. And if you think of scale as how often would you put one of those blue lines? You're trying to put a line every 3 units, and that's an awful lot for this. That's 120 units apart. So it's just too much. So it would look better if we did something like every 10 units put a grid line. Similarly, our Y's are going from 30 to 242. This must be left from some other problem I did, because there's a scale there of 3,000. So that doesn't work either. I think on the handout I went every 30 degrees. Right? Again, this is totally optional, because you don't have to change these scales. But sometimes the question comes up. So let's see what happened. If we exit from view window, we press the graph and graph 1, we now see nice grid lines on this particular scatter plot. Again, by what we determined, every 10 minutes on the x-axis, every 30 degrees on the y-axis. All right, just one of those things I appreciate that the Prism can do. It has such nice resolution, color options. You can see these thin grid lines if you like them. All right, speaking about a little bit of statistics, we've got a nice scatter plot here, nice kind of pattern, but I think the short version would be a linear model could be done here, but it's probably not the most appropriate model. Surely we would agree that some curvature is evident there, and we would fit a different model would probably be more appropriate. I think one of the challenges in teaching for me as an AP statistics teacher, but whether it's AP or not, even introductory college, one of the challenges is, okay, so what kind of curve should we use? I mean, there's all kinds of wonderful opportunities to talk about things that students have learned in mathematics about the way different functions are shaped and so on. We would like to do a transformation of these data, but again, I think it's helpful to say for the record, just a glance at a data set and a scatter not totally determine which way to go. However, in this scientific example, we had some help from a pretty smart guy named Isaac Newton, because there actually is a model called Newton's law of cooling, which describes via differential equation how this phenomena of bringing a hot liquid in, how it would behave. And therefore, I'm going to use that concept to suggest that we've got some evidence for how this would behave. However, there's another little twist, which is that although an exponential model is most appropriate in this case, these data are not trending towards the x-axis. We have what I believe is fair to say some asymptotic behavior going here, but it is going on, again, the quest for equilibrium with room temperature. And so the coffee really isn't going to get colder than the room. That would make an extra twist in trying to find the coefficients for the model. So here's what I would recommend to begin as far as transformations. I would shift the data to change the y variable to the difference between the temperature of the coffee and the temperature of the room. In other words, a quick subtraction would shift this graph downward and make actually an easier model for us to work with. So let's see how we would do that. I'm going to leave the graph for a minute by pushing the exit key. Take us back to our list editor. So you may recall a suggestion that I said at the beginning on the top of the handout. Oh, there's a third column on that handout, and we'll refer to it. Well, here's where I'm referring to that. But that long. Go ahead and do the more sensible approach. Let's let the calculator do the work.
Hey,
now,
John?
here's an important feature. If you want to, yes, sir.
I'm sorry. Your audio just cut out for a second, so I just wanted to make sure we heard what you were just explaining about list 3. We lost about the last 5 seconds. I'm sorry.
I'm sorry. Yeah, I had a little message too that said that there may be a little bit of with the internet connection, but I'll try and keep an eye on that for us. Thanks. All right, so what we're going to do here is to put a formula in a list. Most important technique when doing that is make sure that you use the up arrow on the cursor wheel so that you're on the name list 3, not on the label area and not where the first value goes, all the way up top on list 3. And I would like to define list 3 as the values of list 2 subtract 72. What you have to do is actually type that formula. It's not evident here, but you'll see in just a moment, especially if you've never done this, that our formula will appear in kind of this blank area right here on our screen. So it's a little reassuring to see something when you do this type of an edit to create a formula. In this case, I want the name list. It's not on a tab right now, so the easier version right now would probably be to notice, please, that the word list is in yellow characters on the 1 key. So it is Shift 1. So again, may I just to make sure we're all together here, draw attention to the fact that it now literally says list in this kind of edit space. If that's working for you, then we say we're going to take list number 2 minus room temperature, which was 72. I'm going to leave that on the screen for just a second. Again, if there's anything strange, type in a question for us. We'll try and make sure everybody's okay. But our cursor is on the name, list 3. We're typing the formula, list 2 minus 72. When we hit the execute key, it should generate the new list for us. There we go. 128, 76, and so on. All right, I think I'd like to make a second scatter plot then, and just to demonstrate something, we're going to go ahead and show both scatter plots. So let's go to our setup or our set command again, set This time, let's change that to graph number 2, pushing F2, so it says stat graph 2. Another scatter plot. This time, yes, we're still going to use list 1, but now we'd like to see list 3 for Y. Because we're going to have multiple graphs going on, I also recommend that you scroll down a little bit and change the graph color. I believe the first one was blue, so in this case red will be fine. To change colors, notice the tab above F1 provides the opportunity to do that. So one more time, graph 2 is a scatter plot of list 1, list 3 in red. Press exit. Now, here's something to be careful about. If you push F1, you see graph number 1. If you push F2, you see graph number 2 only. The way to see two graphs at the same time is make choice F4. It says select above there. F4. Number 1 is on. We'll cursor down to number 2 and also use the F1 key so they're both on. And then from this screen, you want to push F6 that says draw. There we go. And again, I really appreciate the prism color in an example like this. What we've really done there is taken our original data, which appears as blue. We've subtracted 72, so essentially it's done a vertical shift downward to, as we see in red. And it is the red that is here to fit an exponential model to rather than the blue. So hopefully everyone has been able to get this second scatter plot. Type in any question or comment that you might have at this point.
It seems like everyone's with us so far.
Very good. Now, it sort of depends what course you're in as far as where you would go, but I'm going to come at it from the perspective of actually teaching a statistics course, as opposed to perhaps an Algebra 2 where you might skip the following part and kind of use the built-in features of the calculator as a shortcut. But a little bit more about this, since our focus of this webinar was supposed to be regression. Let's talk about how that really works in a case like this. We're going to do yet one more transformation, which will essentially straighten out these data. And part of the reason for the shift downward is to make that step even nicer. So an exponential fit like this should be accomplished by a logarithmic transformation. So let's go back to the list editor one more time. And again, the procedure is press exit. We come back to the list editor. I'm going all the way up to the name list 4. And I would like to take the logarithms of these values that we have in list 3. Which logarithm you use is really a matter of personal preference. A lot of teachers seem to prefer the base 10 common logarithm because more students may already be familiar with that, whereas I think maybe calculus and physics teachers have a little preference for base E. Doesn't matter to me, pick your favorite, but I'm going to go ahead and use base 10 log in this example. Now that you see where we're going, I have one comment to maybe save a little issue that I've had in the past by not being too careful. If you go down, if you record your data and your coffee gets all the way down to room temperature, and you have a 72 and you subtract 72, and now list 3 contains a 0, you're going to have rejection trying to take the logarithm of the 0. So the suggestion here is, as I did, keep the values above. Even 73 is fine. You can even put 72 point something. But just learn from a mistake I had once with an error message when I tried to do the logarithms. All right, so once again, my cursor's on a name list 4. I'm pushing the logarithm key here in the 4th row. I believe we should put parentheses here. We could actually get away without them. Shift list 3. Close parentheses. And list 4, we should be generating then those base 10 logarithms. You should see these decimals appearing in list 4. Time for our 3rd scatter plot. Let's go to set. This time graph 3. We'll now have a scatter plot using the values in list 4. Execute. Might as well use another color. Just helps me keep track of what's what. So I'm going to have some fun and say, how about green for this one? Just another comment. You even have a choice here of even changing some of the marks. And in fact, with green, maybe solid would be nice. Totally optional. Most importantly is that it's a scatter plot of list 1 and list 4. Exit. Use F3 to see graph 3. And there we go. Scatter plot. And we have pretty nicely straightened the data. Again, I notice my horizontal grid lines are not visible. Not critical, but the reason now being because we took logarithms, our numbers are considerably smaller. And so that scale of 30 is no longer appropriate. A scale something like 3 would be more appropriate if you wanted the grid lines. I may have forgotten to execute that. I don't want to take too much valuable time worrying about the grid lines so much. Oh, 3, I'm sorry. 3 was a poor choice. I really meant 0.3, not 3. That explains why nothing was visible. Sorry about that. There we go. Again, notice with nice scaling. One of the advantages, reasons I like to do that is here, again, this is pretty nice on an inexpensive handheld device. That we actually have our labeling, our scaling. Notice it's going 10, 20, 30 here, and 0.3, 0.6, 0.9. So again, that's my bias, but for me, it's worth the extra few moments to go into that viewing window, set up that scaling. I get nice labeling right on my screen as well as those grid lines. All right, I think we have accomplished the following. We now have a plot for which a linear model seems most appropriate. This is now at this point, this is the same as what we did in the previous webinar, which is to look at a regression. But let's recall, how do we do that? We go to the calc or calculate choice, F1. We're going to choose actually F2, again, for linear. X squared would be quadratic and so on. So F2. And again, statistically, I prefer A plus BX, but either is fine. And we have computed the coefficients for the least squares regression line. We have correlation, and I just want to observe it's negative 0.9993, We're going to speak about that number again in a few moments. Another optional step, but I highly recommend it, is when you've done one of these regressions that you use F5 to copy that to the y=, editor. In this case, it doesn't matter where you put it, but I'm going to put it in Y3s, and the green will go with the green. I'm sorry, I just did something without saying what I did, which was to hit the F6 for the draw to see this. And you may say, well, it doesn't look very green right now. That's true. When you use that particular draw command after after you've done the linear regression, it does appear as a thin blue line at first. And that can be changed. We'll see that. I want to do a little bit more with this. We have enough time that I'd like to go a little further and speak about our original data. But what I hope we've done so far is we've taken the temperature, we've subtracted the room temperature 72 to shift down the plot. And then with an assist from Isaac Newton, we decided that a good approach would be to take the logarithms of those values and got a nice straight scatter plot, and we fit a least squares regression line to that. We're going to continue and say, well, what about the original curve? But again, any commentary or questions for what we've accomplished so far, now would be a really good time. Otherwise, let's talk about some mathematics of what's happening here for just a moment. I'm bringing back this as a convenient way to share this thought, that what we've really got is a variable here we got a line, a y= was the result we just got. And yes, these have a little rounding to 4 decimal places, which makes a minor difference. But what I want to reinforce is that was really the third change we made. So again, it was the original values minus 72. So this letter y would correspond to the differences in the temperatures that list 2. And so I put the log command here in front to reinforce what we're talking about, that we really have the x and the log of those y's for which this linear model was appropriate. And what I'd say is, well, what if we really wanted to fit the curved data with a curve? Here's where a little bit of math comes in, where if log y is equal to this expression, then y itself would equal 10 to that expression. And I'll come back to this in a minute, but that leads me to suggest that the fastest way to actually do that process would be, I'm going to exit back. I apologize, that's not what I wanted to do. My mistake. What I wanted to do was push F2 to define a graph. So I'm sorry if I messed you up there. Press your graph key again. Here, let me demonstrate. I went here by accident. So I pressed graph 3 to bring it back. And what I wanted to do was choice F2, define a graph. And I'm just going to eliminate that first one because that's something old. Okay, so what I have here is the line, if you will. What I'm interested in doing is now I'm creating a new function by taking 10 raised to that expression. And the easiest way to do that is 10, and then the power key from row 3. And now to tell it this function, which I apologize, I think I stored in Y1 in the handout, and then I decided to make green go with green. It's here in Y3, doesn't matter. But here's what is important. When you want to refer to Y3, don't use the alpha Y character. Use this bold Y that we see in the tab. Okay? So I have 10. I press the arrow key. Because we're in nice natural display, we have a raised exponent, but that caret symbol doesn't appear. But when I hit F1, Y3. Cool. Don't forget to execute. It should turn red. Now, I want to exit and bring back graph 2. If you'll remember what graph 2 was, it was the shifted data of the scatter plot that was curved. There it is. And if I go back to the define the graph and deselect Y3, what do I mean by select, deselect? This F1 will turn functions on and off for graphing purposes. Notice the equal sign on my Y3 is not highlighted, so it won't be graphed. And the equal sign on my Y2 is highlighted, so that will be graphed. And now if I draw, I have a nice curve that actually goes through the list 2 scatter plot. I'm going to try and tie all this together in a moment by suggesting that, again, if you glance at the handout, even if it's later, there's some more good mathematics here, I think. Here's what we have. Y hat equals 10 to that exponent, or 10 to this value multiplied by 10 to that value. You can see off on the right, I don't think I'll do it in the interest of time, but I simply went to the calculating menu, the run matrix menu, and actually estimated these values. So what this suggests is the typical way to run as an exponential would be this, 129.33 times 0.9482 raised to the x power. That's your y equals a times b to the x form for this function. And I think the important action I'm trying to make is, yes, many of you know if you go to the calc menu, instead of linear or even these polynomials, go to F6, and here's the built-in exponential regression feature. If I push F3, and I'll get this form, a times b to the x. Hopefully those numbers look very familiar. My point being that we could have just used this EXP regression shortcut, and you might choose to do that, say, in Algebra 2. But I hope what we've just done is made it clear how that really works. In other words, there really isn't an exponential regression. Even this calculator internally does just what we talked about. It uses a logarithmic transformation. It does a straight line, least squares regression fit, and then it kind of takes care of the transformation just as we did by raising 10 to the appropriate values to come up with these coefficients. And I must draw attention to one of my pet things here, which is, here is a value of r that's displayed under exponential regression. And I think that is potentially a source of great confusion. A correlation coefficient r measures the strength of a linear association between two variables. So why do we see this r that's so close to -1 on this curved thing? And the answer is, remember when we did the linear regression? That's the exact value of r we got when we did the linear regression. And this is simply duplicating that value. So this value of R corresponds to the transformed scatter plot, and not the, if I could call it, the green straight scatter plot, and not the red curved scatter plot. And when you just do the kind of exponential regression as a magic button shortcut, I don't think that's very clear where that R really is computed from. So I do take every opportunity to talk about that a little bit. Again, we can copy this wherever we want it. I'm going to put it here in Y4. Execute, draw, and you can. Really it's the same as what we did by the longer method, and so that should correspond well. Finally, for our grand finale, one last thing, we could actually go back there and say, well, what about our original data? The very first two lists we had, list 1 and list 2. Remember, that was in graph 1, and it looked like that. Is there a reasonable model for that? Well, sure, at this point there is. Let's go in to define the graph. We have a really nice model here. It can either in Y2 or Y4. Both of those are nice curves for the shifted down. So really all we have to do here is add the 72 back in. So check this out. What if we made Y1 equal to Y2? And again, please remember to use this tab, Y2 plus the 72 that we subtracted off the first time. Execute to turn it blue. I'm going to use the select feature to turn the rest of them off. So one more time, Y3 was the straight line that fit the green scatter plot. Y2, we took 10 raised to that and got a nice curve for the shifted down red scatter plot. Finally, I'm putting the plus 72 back in, which would shift it back up and hopefully fit the original blue scatter plot. Let's make sure that's true. F6 to draw. There we go. And I think we have generated a nice example that of a model that fits our data extremely well. But instead of just quickly going through that, we went through the details of how these coefficients are actually computed by our PRISM and in fact by statisticians who do this type of curve fitting. We do have a little bit of time left, and we'd be pleased to take any last comments or questions that are related to that example. If anything towards the end there was not quite so clear, I'll try and help with that. Certainly thank everybody again for being with us again this week, and hopefully you appreciate how to use your PRISM to do some of this modeling.
I'd like to chime in and also thank everyone for joining us. And again, if you have any questions, now is a good time. You also should have my email, so feel free to contact me at any time. Well, I'm not seeing any questions. So.
All right. Well, again, certainly doing this type of modeling is one of my favorite parts of the disciplines of math and statistics. I've enjoyed the opportunity to share some thoughts both last week and this week. So thank everybody who was here for either one, especially a couple of you who were here for both. And maybe we can create a few more statistical webinars sometime in the future.
Just saw a comment.
Please. Yeah.
Sorry, I just want to throw out we had a well done and a thank you, and I want to throw my thanks. Want to throw my thanks in as well. It's like I was saying, I've taught statistics before, but there's a few little details that you bring out here that I enjoyed. I kind of saw it coming since I got an advanced copy of the handout, but that bit about R being linear, even though you get an R value for the exponential model, that was great because it's something that I just totally whizzed over my head. I'm sure when I taught it, it's a minor detail that is all too easy for me to overlook, but I love it. It's great. So.
Well, good. Yeah. Again, I can't help but mention that when it's one of those where if you use the shorter version, it's just subject to misinterpretation.
Right.
Of what that means. I mean, if you look at what we have on the screen, we've got a really good pattern to these data, but that shouldn't lead to a value of R that's close to 1 or -1, because R's close to 1 or -1 indicate a really strong linear pattern.
Right.
So one more time, what you've said is, and I'm going to reinforce, is that R belongs to that picture.
Yep.
And when you don't do the long way, it's not very obvious where that R came from. Thank you, sir.
Well, thank you. Thank you, everyone, again for joining us. Keep an eye out for future webinars, and if you are not getting notification, please drop me an email, and I'll make sure you get notification of future ones, and I'll let you know where you can look on our website as well. So thanks again. Thank you, John, and everyone. I wish you a good night.
Yes, good night, everybody.